This lecture deals with browser fingerprinting, which is a special form of device fingerprinting. As I discussed in the reconnaissance lecture, fingerprinting is the process of determining the characteristics of a remote service or machine, in this case a web browser. The purpose of fingerprinting in a recon context is to obtain information about a target to aid potential future attack. Here the purpose is very different. The browser is fingerprinted not to attack it, but to track users online. So here we're really talking about a threat to online privacy. If they can get an accurate fingerprint of your machine, then they can track you online simply by comparing a fingerprint they see now with the contents of a fingerprint database. So what exactly are websites conducting fingerprint collecting? What goes into these fingerprints? The short answer is anything and everything they can harvest about the configuration of your machine. This includes a vast array of things, including your screen resolution, and whether you have multiple monitors, the list of browser plugins you have installed, your list of system fonts, your operating system version, your browser version, what cameras and microphones you have installed, and many other things. All of this information taken together provides a fairly unique fingerprint that can be used to determine whether different visits to a website were done from the same machine. Websites do this as a countermeasure to your attempts to thwart their tracking efforts, which you would typically attempt to do by disabling cookies. Note that websites have another countermeasure that I won't go into here. I'm referring to the so-called super cookies, such as the ever cookie, which is a technique to restore cookies you delete from backups stored without your consent in various parts of your system that code running in the browser can access. Note that because fingerprints are a snapshot of your device's configuration, they change over time. Hence, they're not a silver bullet for tracking and need continuous maintenance. Be aware that browser fingerprinting is no merely academic concept. It is actively being conducted on the internet commercially, and if your anonymity and privacy is important to you, you need to understand the threat that fingerprinting represents. Before I discuss how fingerprinting works, I want to say a few more words about why some websites are doing this. The fingerprint gives them a means of tracking you, as I mentioned before. Note that a fingerprint doesn't tell them who you are, but simply allows them to determine whether two visits to a website are from the same device. However, they could tell who you are if you ever visited a site non-anonymously and they grabbed a fingerprint at that time. Other than tracking, a common motivation for fingerprinting is fraud detection. Here's a quote from a fingerprinting patent application that gives some insight into the motivation of one commercial fingerprinting company. Quote, "A system that uniquely identifies network devices connecting to a network and correlates logins with each network device used to observe login behavior, such as accounts connecting from too many devices, or too many accounts connecting from the same device, to cross-reference physical devices used by known fraudulent accounts, and cross-reference other accounts used by specific devices, physical devices involved in suspicious or fraudulent activity, or devices associated with accounts involved in suspicious activity that can be prevented from connecting to a network." Unquote. What we see here is an example of a third-party fingerprinter. What this company's patent is describing is a commercial service that they sell to websites for purposes of fraud detection and other things. So if you're getting fingerprinted, it may not even be the website per se that is doing it. It could be a fingerprinter for hire, like this company, who might not even share the fingerprint information they collect with the company of the website you visited. They may only share a risk score of some sort, based on the fingerprint they collect. So let's talk now about how fingerprinting is done. There are many methods, and I'll only touch on a few here. One category is direct inspection of HTTP data or mobile code objects, such as those in JavaScript and Flash. HTTP discloses information about the browser and system in its headers. For example, the types of document encodings the browser supports and its accept encodings headers element. The user agent header element discloses browser type and version, as well as other information such as the operating system version. JavaScript and Flash are a treasure trove of fingerprint data, and I'll give some examples of those on the next few slides. Canvas fingerprinting is a way of discovering systems characteristics in the way graphics and text are rendered on your browser. The fingerprinting code will request that something be rendered, perhaps invisibly to the user, and then it will inspect the rendered result to detect differences in various rendering engines. Cache and history snooping is a way of seeing what is in your document or DNS cache because this tells them something about where you have previously browsed. Older browsers, for example, permitted script code to obtain your browsing history via canvas method that invisibly put links on your page and then inspected them for the visited link style that indicated you had previously been to that page. DNS cache snooping works by forcing a name resolution against a target domain and then timing the length of time it takes for the resolution to occur. A short time is indicative of a DNS cache entry in your system for that target, indicating that you had recently visited the target site. The last category of fingerprinting I'll mention is JavaScript performance testing. Since the browser, operating system, and underlying hardware all affect the time it takes to perform computational tasks, measuring the performance of JavaScript operations can reveal information about these system components. Let's consider HTTP and browser object inspection in some detail. For HTTP, the main fingerprint data source is the user agent string. Here's an example from my system. You can see that it gives a very detailed Chrome version along with information about the operating system. Windows NT 6.1 can refer to a few versions of Windows, including Windows 7, which is my OS. Note that you can change your user agent with various tools if you want to prevent this information from being obtained by websites. However, do this with care. If you simply change the user agent string to some other value that is fairly unique, and you leave it at that value, it can still be used to fingerprint you. Also note that a privacy tool may give itself away. For example, the Panopticlick study that I'll mention at the end of this lecture found user agent strings containing the word Privoxy, which is the name of a privacy tool. Obviously, if you're concerned with privacy, the last thing you want is to advertise the fact that you're using a privacy tool, or worse, to disclose what that tool is. Let's consider JavaScript now. JavaScript is commonly used in websites for basic web page functionality. You could disable JavaScript to prevent websites from getting the fingerprint data we'll discuss, but then you'd be crippling your internet experience. Chances are you have JavaScript enabled and are vulnerable to this sort of fingerprinting. Before I discuss specific examples, let me show you how you can see this data for yourself. We'll use the Developer Tools functionality integrated in your browser that you may not be aware of. It will allow us to run JavaScript commands directly and see the same data that a website would be able to obtain if they embedded JavaScript in a page that you were viewing. First, open your browser. I'll use Chrome for my examples, but any browser should work. Next, right-click anywhere in the page and select Inspect Element in the pop-up menu. This will open your browser's Developer Tools window at the bottom. Next, select the Console tab in the Developer Tools window. The console prompt is at the very bottom of the browser window. Enter JavaScript commands or object names here, and details about the object will be displayed in the window just above. This allows us to inspect the objects. We'll see examples on the next slides. First, consider the screen object. This object reveals my screen resolution, including the fact that my Windows taskbar is not hidden and is positioned horizontally. We can tell this from the fact that the height of 1080 pixels is different from the available height of only 1040 pixels. Those 40 pixels of difference are being taken up by my taskbar. If the taskbar were hidden, there would be no difference between these values. Now let's examine the Navigator object. If you type Navigator at the prompt, you'll see a list of objects it contains, one of which is an array object called plugins. This array is a fingerprinting goldmine. First, type navigator.plugins to see how big the array is, and then type navigator.plugins index close bracket, where index is an integer starting at 0, to see the details of a particular member of the plugins array. Here is the first element of my plugins array. Note that we have a name, Google Update, a DLL file name, and a very specific version. If we walk the entire array, we'll harvest a lot of valuable information about the plugins on the system. Flash is another mobile code technology like JavaScript that provides objects with system properties. Flash is particularly useful for obtaining the list of fonts installed on your system. That data is in an object called fonts and is accessible through the enumerateFonts method of that object. Because systems can have very large font collections, this data is highly valuable as a fingerprint. On my system, for example, the list of fonts is 4,902 characters long. There are probably not many systems with exactly the same list of fonts as mine. Because Flash code must be compiled to run, we can't inspect Flash objects as easily as we can inspect JavaScript objects. However, you can see your Flash font fingerprint data by going to the Panopticlick website and running their fingerprint test against your browser. Panopticlick is an EFF study on the potential of fingerprinting. They will show you the fingerprint data they are able to harvest from your system and tell you how unique your data is. Note that by disabling Flash, it will not guarantee that your system fonts cannot be enumerated. This is because there are other ways to obtain that fingerprint data, for example, through canvas methods. So, just how prevalent is fingerprinting in the wild? A few recent studies have examined this. The good news from a privacy perspective is that most websites are not collecting fingerprint data, only a few thousand, so it's not a widespread thing yet. However, browser fingerprinting is a relatively new concept that may become more prevalent in the future. I'll finish this lecture by discussing how fingerprinting effectiveness is measured. The standard metric is Shannon entropy, which is given by this formula and is in units of bits because of the base 2 logarithm. The idea here is that you have a distribution of values the fingerprint can take, and each value appears in some percentage of the population you observe. Entropy is a single number describing that distribution. We can think of it as a measure of how, quote, random, unquote, or uncertain the distribution is. The higher the entropy, the more uncertain is the distribution. For example, a fair coin has a uniform distribution of probabilities over the two possible values of heads or tails. This distribution would have a higher entropy than an unfair coin that landed heads 90% of the time. And a coin with heads on both sides would have an entropy of 0, corresponding to the 0 uncertainty in the outcome associated with flipping that coin. Let's consider a specific example in the context of fingerprinting. Assume we have a perfect fingerprint scheme, meaning we have fingerprint data that gives us a different value for each unique visitor to a website. Let's say there's n equals 100 total users. The entropy of this fingerprint scheme would be about 6.6 bits, as I show here. This is the maximum entropy possible for a distribution with 100 different values, because the probabilities are spread evenly over all 100 values. With this perfect scheme in mind, let's now consider a more real-world example. Consider a fingerprint consisting of just browser type. Our 100 users are not using 100 different browsers, so we won't collect 100 different fingerprint values like we assumed in the previous case. We might only observe 5. Let's say those are Chrome, Internet Explorer, Firefox, Safari, and Opera, with the probabilities shown here. The entropy associated with this distribution is lower, only about 1.6 bits. Clearly we need more fingerprint data if we want to get close to the desired 6.6 bits of entropy needed for our 100 users. We could add entropy by collecting browser version instead of just browser type. Of course, real-world tracking deals with far more than just 100 users, millions in fact, so we need a lot more than just a few bits for an effective fingerprint. Fingerprint studies have examined the entropy associated with various fingerprint data, so we know what the effective ones are. For example, the Panopticlick study found that browser plugins at 15.4 bits, fonts at 13.9 bits, and the user agent at 10 bits are some of the most effective individual fingerprint data elements. Obviously, combining these into a composite fingerprint will increase the entropy over that of any one fingerprint element alone, which is why fingerprinters will try to collect as much data on you as they can. I'll conclude this lecture by encouraging you to see your own fingerprint data. You can do this by visiting the website panopticlick.eff.org and running their test. Although the Panopticlick study has concluded, they still provide access to their fingerprint web application for educational purposes. This website will show you your fingerprint data, along with an associated uniqueness metric in bits. Note that the bits of identifying information reported for your data by this site is not entropy. It's a related quantity called surprisal. Read the Panopticlick study for more information.